Oh, okay. Good. So let's put it back in, and then now that we have a function of x. Once we get the function of x, all we need to do is differentiate it. So now this becomes a function of x. I have 12x plus 8 multiplied by this. So 8 times 384 over x minus 8 plus 8 times 12, 96, plus 288. So then a of x, 12x plus, I just want to quickly multiply those. So 384 times 8, 3072 over x minus 8. And plus this number doesn't count because it will disappear in a minute. Of course, it's 384. Okay, so finally we have the function. So let's find a prime of x. So this is 12. This disappears. And plus, I don't like this, but I don't like using a quotient rule on a fraction with just a number at the top, because the top prime is 0 times the denominator, so it's still 0, minus the top times the denominator prime over the denominator squared. It's okay. So let's do this again. This prime is 12. This prime is gone, 0. Now this fraction prime, the top prime is 0 times the denominator. So this, if you want to write it to make sure you're not missing anything, it's 0. Minus the top times the denominator prime, which is 1, over the denominator squared. So then finally we have, what do we have? We have 12 times x minus 8 squared minus 3072 over x minus 8 squared. So a prime is undefined when x is 8. But it cannot be 8 because if x is 8, 8 minus 8 will be 0, and this is 0. So that's not possible. And a prime of x is 0 when the top is 0. So 12 x minus 8 squared. Move this to the other side. So then x minus 8 squared. Let's see what 3072 over 12 is. If it's divisible, we don't know yet. Divided by 12. Awesome. 256. And when we take the square root of 256, we get, of course, 16. So we take the square root. X minus 8 equals plus or minus 16. And x equals 8 plus or minus 16. So one option is x equals 24. And the other option is x equals negative 8, which is not an option. So we claim that x equals 24 will give the minimum area of the poster. But it's just a claim at this point. So we say that this is 24. And what is y? Where's my y? Okay, here's my y. 24 minus 8 is 16. And we figured out that 384 divided by 16 and plus 12. 36. Okay, we'll check in a minute. And everything was in centimeters. So we claim that x equals 24 gives a minimum. Who knows? Who cares? We have to show anyway. So we have x We have a prime of x, and we have a of x. So we had 24. And I go back to this ugly thing. When I plug in 0, this is 12 times 64. And I just want to see if 12 times 64, that is smaller than this. Okay, so this is negative. And if I plug in, what do I want to plug in? 30. 30, so 12. And then 30 minus 8 is 22 squared minus 3072. This has to give us a positive answer, and it does. So I checked everything. So this is definitely a minimum. And in case we're asked to find the minimum area, where is my function? Here is my function. So that's where I have to plug in 24. So 12 times 24 plus 3072 divided by 24 minus 8, which is 16, and plus 384, and I get 864. So this is 864 centimeters squared. So we determined the dimensions of the poster given the restrictions we had, and we figured out that this was the width was 24, or the base was 24 and the height was 36, and the minimum area was 864 centimeters squared. Any questions on this problem? Any questions? I hope by Wednesday you're going to look at the problems in WebAssign and you're going to say, let's do this, let's do this, let's do this. So I like now to go through a list of possible questions on this test. It's not a lot. So test 3. So here's the first one, Newton's method. Number 2, optimization. Of course, one problem of this and one problem of that, not more than that. Okay, number 3, Rawls plus the mean value theorem. Not both, one or the other. One example, one question. Number 4, a graph from the beginning to the end with f prime, with f double prime, all the work, and definitely the table. Max min, inflection points, concavity, potential hole in the graph, asymptotes, all limits. Number 5, L'Hopital's. L'Hopital's theorem, or L'Hopital's rule, with 7 indeterminate cases. I cannot think of anything else from this chapter. I'm going through the pages. Max min. Oh, yes. I don't want to forget. Max, it's normally absolute max, absolute min on a closed interval, where the domain is given to us, in other words, and it's a closed interval. I'm going through pages, increasing, decreasing, first derivative test. Oh, yes, I don't want to forget the gibberish. Graph, based on info given. That's it. So the graph, I may not ask you to graph with the slant asymptote, but please remember the slant asymptote and how to determine it. There is absolutely nothing else. No other type of problem is possible because there is nothing else. That's it. So these are the 7 questions possible on the test on Monday. So 11/13. We have plenty of time, so let's start. What would you like to work or go back to? Any type of problem you'd like to see again? Anything. We just worked on these 2. Now it's up to you. We can continue or we can choose something else. Whatever you want.
Can we do the gibberish?
Yes. Let's look at the gibberish. The gibberish is, where is the gibberish?
I think it's 4-3.
Exactly 4-3. Yes. Perfect. Great pick. So let's choose in 4-3. Please work on all the web assigns so you can ask questions so I can help you with those problems in class on Wednesday. So here's the gibberish. Anything you want. We also had a homework problem. And let's choose.
I think I had one in my web assignment I was having.
Absolutely. Yes, yes, yes. Let's do it.
I'm trying to pull it up.
Awesome. So if you want to dictate, I'll write it down. Great job. Absolutely. That's the best. So we can move on from that. Please remember all WebAssign has to be completed by Sunday so you can take the test on Monday, please. It doesn't work, as you've noticed.
So
I'm ready.
The gibberish right ones aren't in WebAssign.
Yes. Any problem.
But there's one, so it's to find the inflection.
Yes, anything you want to work on, let's work on it now.
Okay. It's find the inflection of the curve.
So the inflection point, yes, f of x.
Equals 1 plus x all over 1 plus x squared.
Perfect.
But it says, hint, all 3 lie on one straight line. Enter your answers from smallest to largest.
Okay. Perfect. So in order to determine the inflection points, we have to get to the second derivative. The second derivative is the one who gives us concavity and inflection points. I cannot, from the first function, from the function, get the second derivative without going through the first derivative. So I have to find the first derivative first. It's a quotient, so I have to use the quotient rule. The denominator has to be squared. The top prime is 1 times the denominator minus the top in parentheses times the denominator prime, which is 2x. Remember, I always say factor, factor, factor. No, in this case, we can't. So I have to distribute. So 1 plus x squared minus 2x minus 2x squared over 1 plus x squared. I said squared, but I didn't put it. Okay. So now, negative 2x squared plus x squared is negative x squared. Negative 2x and positive 1. 1 plus x squared squared. Let's do this one more time just to make sure I didn't forget anything. Top prime is 1 times the denominator minus the top times the denominator prime. I copied, I distributed negative, I distribute negative again. Then I have negative 2x squared plus x squared, negative 2x and plus 1. Too many negatives. I'm allergic to the negative leading coefficient. Now I'm ready to differentiate again. This means nothing because we are asked to determine the inflection point, so I have to get to the second derivative. But without this, I cannot get the second derivative. This is awful, but that's what I have to do. Now the next step is also awful, but I have no choice. Top prime, 2x plus 2, times the denominator, minus the top, times, of course I will run out of room, the denominator prime. So I'm going to do this. The denominator prime is 2, 1 plus x squared times the inner function prime. Okay, let's do this one more time. Negative stays outside. Top prime times the denominator minus the top. But now when I differentiate this, I bring down 2. I subtract 1 from the power times the inner function prime. All this should have been here, but I don't have enough space. Now, if you don't factor and simplify, this will take forever. And we may not even get there. I have to factor. I'm going to write it one more time for everyone to see. And then I will factor as much as possible and then simplify. Okay. $15. Okay. So the second derivative, negative 2x plus 2, 1 plus x squared squared minus 2x times 2, 4x, x squared plus 2x minus 1, and 1 plus x squared. Do not distribute. Do not expand. Don't touch anything, please. We have to factor as much as possible. So I will have to factor 1 plus x squared. This has to be factored, and 1 from here. So 1 plus x squared is out. And the beauty is this. But after you factor out, not before. So I have inside 2x plus 2 times 1 of these. This is gone. It's in front. But now I have to distribute negative 4x. Negative 4x to the third. Negative 8. Negative 8x squared and positive 4x. Distribute. Now I have no choice. I have to distribute. 2x.
What is that? I'm sorry. After the minus 4x cubed, what is that?
So 4x times
No,
this.
below that.
Yes.
Mm-hmm.
So
Oh, so minus 8x.
yes. So 4x, let me check just to make sure. 4x times 2x with minus in front, negative 8x squared, and 4x times negative 4x times negative 1, positive 4x. So 2x times 2 and 2x times x squared. So 2x cubed. 2 times 1 plus 2x squared minus 4x cubed minus 8x squared and plus 4x. And nothing disappears, but that's what it is. Okay. So I have an x cubed with another x cubed here. So that's negative 2x cubed. Then I have x squared and minus 6x squared. Then I have 2x with 4x. And then I have a 2. Please be allergic to negative leading coefficients, please. So I distributed this negative to eliminate the negative leading coefficient. And then the second derivative is 0. It will not be undefined. And when 2x to the third plus 6x squared minus 6x minus 2 is 0. Yes, I will divide both sides by 2. So x cubed plus 3x squared minus 3x minus 1 is 0. I can factor, but it's factorable. But here it is. You are allowed at this stage to use the apps. The 9